All right, so today we're starting section 7.3, and it's all about determining whether or not something is a parallelogram. So if you remember the properties that we talked about yesterday with parallelograms, those are going to come into play today when we talk determining whether or not something is a parallelogram. And this is going to lead us tomorrow into things like proofs about parallelograms. But before we get ahead of ourselves, let's just look at our properties. So how do we know if a quadrilateral is a parallelogram? Well, if any one of these 5 things are true, then we can say it's a parallelogram. So first off, if both pairs of opposite sides are parallel. All right, so that one should be fairly obvious. That's kind of the definition of a parallelogram, right? A quadrilateral with both pairs of sides parallel. But also following that, if both pairs of opposite sides are congruent, then you can also say that the shape is a parallelogram. So if we're kind of making something off to the side here, parallel versus this one with opposite sides being congruent, just to kind of keep track here. The third one, if both pairs of opposite angles are congruent. So far, this is everything from our properties that we talked about yesterday in 7.2. Then the figure is a parallelogram. We got both pairs of opposite angles congruent. Then also if the diagonals bisect one another. So if they're cutting each other in half with the diagonal. So if we've got our diagonals drawn and those 2 pieces of that diagonal are congruent and those 2 halves of that diagonal are congruent, then we can say that it's a parallelogram. And then finally, there's one new one we're going to add, and it's if one pair of opposite sides are both congruent and parallel. So this one's a little bit different for our picture here. We're going to have one pair of opposite sides, they're congruent, and then they're also parallel. So if that's true for a full pair, then you can say that the shape is a parallelogram. So those are our 5 properties. It's the same 4 from yesterday and then one new one. And so using this, there's a couple different types of problems we can do. The first kind that we can do with example 1 is determine whether or not something's a parallelogram. So you might be given a picture with some markings on it, and we have to decide if these markings are enough to dump it into one of these 5 categories here. So if we're looking at this first one, we notice that these 2 segments are congruent and these 2 segments are congruent. This looks a lot like the 4th property here. The diagonals bisect each other. It's the same kind of picture that we had there. And so in this case, that is enough to say, yes, this one is a parallelogram because the diagonals bisect. All right. So if you say yes, you have to have some kind of a reason. If you say no, then you might just say like not enough information or something like that. So then looking at the second one, we might notice that there's these angles that are labeled. Opposite angles congruent, other pair of opposite angles also congruent. This looks an awful lot like the third one. Both pairs of opposite angles are congruent. And so that is enough information to say, yes, that is a parallelogram because both pairs of opposite angles are congruent. And you can use some shorthand if you want to. The angle symbol for angles and the congruent symbol for congruent. But that would be our reason for it. The third one is also going to be is this enough information to say if it's a parallelogram? So if we look at this one, we've got one pair of sides that are congruent because they're both 12. And then this is actually a parallel symbol. These are both parallel here. Is that enough information to tell if it's a parallelogram? So then we have to look at this and go, okay, well, we don't know that both pairs of opposite sides are parallel. So not quite. We just have one pair. And we don't have both pairs of opposite sides congruent. We just have one pair. We don't know anything about the angles. The diagonals aren't even drawn in this picture. So the last one we have to look at is this fifth property. Is one pair of opposite sides both congruent and parallel? And we see that we've got one pair of opposite sides parallel and one pair of opposite sides congruent, but they're different pairs of sides. It needs to be the same pair of sides that's both congruent and parallel. So this one actually does not work. This one is no, not enough information. All right. So there's our first three, and those all went fairly similarly to one another, right? We were looking for a property that works with those. Now, example 4. There's a couple ways that you can approach the fourth one. We know that it has to work with angles, so we would have to set, opposite angles equal and stuff like that. When we do this, there's a couple different things that can happen, or ways we can think about it. One way we can think about this problem is to go and set this pair of opposite angles equal and set this pair of opposite angles equal and see if we get the same y value for them. Because if we do, that means that it works out that they would be both pairs of opposite angles congruent. Another way you could do it is knowing that all 4 angles on a 4-sided shape will add up to 360. We could add all of these to 360 and then plug in the y value that we get and see if the opposite angles are congruent. On this one, you might also have noticed that 3y plus 45 is both of these. So we don't really have to set that one equal. We can just set these two equal to get a y value that would work. So that's probably what I would do here, is just set these two equal to one another. But if you had 4 different angles here, I might try adding them all and setting it equal to 360, see what you get for y, and then plug it in. But in this case, I think I'll start by trying 2y plus 15 equals 5y minus 57. So then we want to go ahead and solve this. So we go minus 2y on both sides. And then, oops, can't quite see it anymore. Plus 57 on both sides. So we get 72 over here equals 3y. Divide by 3 on both sides. And we should get 24 for y. All right. So then we can plug it back in and see what kind of angles we get. 24 times 2 plus 15. That gives us 63 for both of these. And then let's see, 3 times 24 plus 45 gives us 117. So we know that both of these are equal. Both of these are equal. I would double check and make sure that when you add them all together, you get 360, since otherwise it's not going to make a quadrilateral. But on this one, when we go 63 plus 117 plus 117, we do get 360. So that works out. So on that one, there are a few things we have to check, but this one, we can say, yes, it will make a parallelogram because opposite angles are congruent. And actually thinking back on this one, I would probably just add all 4 of them, set it equal to 360, and then plug in the y value that I get. This one worked both ways because it worked out. But if you got the y value and you plugged it back in and then added them all together and didn't get 360, that would be a problem. Anyways. So that's kind of the main type of problem we're going to be working with today. If you turn the page, we start looking at things like the homework. And on the homework, it does have kind of a restatement of our list of 5 properties that we just talked about up at the top. It also has an example problem. For the first 6 problems down here, you're finding x and y that would make the quadrilateral a parallelogram. This is the same kind of problem that we were working with yesterday on 7.2. It's just different phrasing. So on these ones, you're still just going to be setting the sides that are across from each other equal to each other. The angles that are across from each other equal to each other. The angles that are consecutive, adding to 180, stuff like that. So this is the same kind of problem that you worked with yesterday for 7.2. And then on the next page, we're going to see more problems that are like the examples that we did just a few minutes ago. In fact, some of the problems that are on here are from those examples, so you might be able to find a freebie somewhere. So you're determining if the quadrilateral is a parallelogram, so yes or no. If it's yes, you have to include one of the 5 reasons why it could be a parallelogram that we talked about before. If it's not, you can just say that there's not enough information. All right, so go ahead, get started. If you have questions, feel free to ask. Otherwise, have fun. See you later.